Hi, I'm Bob. Let's complete the problem set for Chapter 6, Multiple Regression Analysis, Further Issues. For the first problem, the t-statistic for the quadratic term of the return on equity variable is minus 0.29 and the p-value is 0.77. It is not statistically significant at any conventional level. We can drop it from the model. So, adding the quadratic term to the model is not necessary. For the second problem, the beta hats are the OLS estimates for the regression of y on x1 to xk. We can write the estimated equation as equation number 1. Now, we have beta tildes as the OLS estimates for the regression of c0y on c1x1 to ckxk. We can also write down the estimated equation as equation number 2. Next, we divide equation 2 by C0 and obtain equation number 3. Comparing equation 3 and equation 1, we find the relationship between beta hats and beta tildes. That is what the question wants us to show. In problem 3, we use calculus to show the marginal effect of sales on R&D. The turning point is $21,428.6 million. After that point, the marginal effect becomes negative. My answer to the second question is yes. The quadratic term is statistically significant at the 10% level against a two-sided alternative. Its t-statistic is minus 1.86 and its p-value is 0.072. And the turning point is economically meaningful. In the third question, we defined sales bill as sales measured in billions of dollars. The estimated equation is as follows. It has the same estimated effects and testing outcomes as the first equation. The second equation is preferred for reporting purposes because it contains fewer zeros. Let's find an answer to problem number 4. Using simple calculus, we can show the marginal effect of another year of education on the log wage as a function of parents' education. I expect beta 2 to be positive because children growing up in highly educated families are likely to benefit more from education. Plug in the estimates and we have the marginal effect of education on log wages. If the parents' total years of education are 32, the individual's return to her own education is 0.072. It implies that if the individuals have both college graduate parents, the individual's wages are expected to increase by 7 0.2% for one more year of education. If the parent's education is 24, the estimated return to education is 0.066. It implies if the individual have both high school graduate parents, the individual's wages are expected to increase by 6.6% for one more year of her own schooling. The expected return to education increases with their parents' education. For Part 3, the parent's education variable is added to the model, and it has a positive effect on their children's wages. After controlling for parents' education, the interaction term becomes negative, but it is not statistically significant at the 10% level. The t-statistic is 1.3. The null hypothesis is that beta 2 equals 0. We fail to reject the null hypothesis at the 10% level. The result suggests that after the own education and the parent's education are accounting for, the parent's education has little effect on the individual's marginal educational effect on wages. Let's do the fifth problem. It makes no sense to include the science exam passing rate in the model as an additional explanatory variable. In example 4.2, we used 3 explanatory variables: teacher compensation, the number of staff per 1,000 students, and student enrollment to explain the math exam passing rate. If we add the science exam passing rate to the model, it leads to the over-controlling problem. It's also known as the bad control problem. The science exam scores are also a result of the 3 explanatory variables mentioned above. It is impossible to estimate the ceteris paribus effect of the 3 explanatory variables while holding the science exam scores fixed. So the science exam passing rates should not be included in the model. Let's complete problem number 6. When the 2 additional variables are included in the model, the R² rises slightly, but the 2 variables are not jointly statistically significant at the 10% level. We can perform an F-test or an LM test. They reach the same conclusion. The p-values are around 0.28. They are not jointly significant even at the 20% level. I will not include them in the model. First, the rise in the adjusted R² is negligible. Second, they are not individually or jointly statistically significant at any conventional level. Thank you for doing the problems with me, and see you soon. Thank you for watching this video and subscribing to my YouTube channel. See you next time.